Hey guys, today we are going to talk about compounded interest. Yesterday we talked about calculating interest on a simple loan where you just calculate the interest based on the principal. Compounded interest is different because it kind of like it adds interest on top of interest on top of interest. So in the end, you're going to be paying more with compounded interest than you would for a simple loan. And here's kind of a visual of how that might work. Let's say you take out a $5,000 loan for 4 years at 4%. Okay, so the bank, if it was a simple interest loan, they would calculate the interest that you're going to pay, add it to your principal, and then you would break it up into even payments. So that way it's paid off by 4 years. Compounded interest, you kind of end up paying more because first they take the principal plus the interest. Then, like whatever you don't have paid after that first year, they kind of add more interest on top of it. Whatever you don't have paid from the first and second year, they would add more interest on top of it. Whatever you don't have paid from the first, second, and third year, they would add more interest on top of it. So, like the amount that you are being charged in interest is increasing because they're kind of charging interest on top of interest on top of interest. So, moral of the story is if you were at the bank and they offered you like a simple interest loan or a compounded interest loan, it probably would be better to take the simple interest loan in most cases, not all cases, but in most cases, it would be better to take that simple interest loan. But if you're putting money into an account to earn interest, like a retirement fund, or if you're investing or anything like that, and you want your money to get bigger, right, quicker, the amount that you put in, your goal is to get it to like increase faster. Then you're going to want to take the compounded interest one because it's going to be adding money to your account, interest on top of interest on top of interest. So hopefully that helped you out on when you might use this. All right, the formula that we use for compounded interest looks a little bit different. A equals the final amount, so you don't have to add your principal to your interest. Like using this formula, you're going to get the final amount of that loan. P is the principal, the amount you took the loan out for. R is the interest rate. Remember, that's going to be a percent, but you are going to convert that into a decimal point. N is the number of times the interest is applied per time period, or how many times it's been compounded per time period. If that seems complicated, we're going to go over some examples that will make it a little bit more clear. And T is the time, or like how long you have to pay that loan back. So let's talk about this N, the number of compounds component of this equation. So in an example question, it might give you the principal, the rate, and then for the n, or like the number of times it's compounded, they'll say annually or semi-annually. If they say annually, that means that that interest is applied once per year. So your n would just be represented with 1. If it's semi-annually, that means they are applying that interest twice per year. So then your n would be a 2. If it was monthly, that means every month they're applying interest, so your n would be 12. So hopefully that helps you out. If you have any questions on that as we work through these problems, feel free to ask. Okay, we'll go ahead and start with some examples. So if you do not have your percents, discounts, and loans assignment open, make sure you do so because we're going to go over number 16. Okay. So the nice thing about this one is they give us the principal, they give us the interest rate. It's being compounded annually, and we know that just means 1. And our time is 4 years. So now we just need to take all this information and we need to put it into our equation. So A, that's what we're looking for, equals, our principal is 3,400 multiplied 1 plus, now we need to do R, and R is the interest rate. It's in percent form. We need to quickly convert that into a decimal point just by moving the decimal point over 2 spots. And if we do that, we get 0.08 over n, which is just 1, to the n times t power. And in that case, it would just be 1. Our time is 4. All right, so we put all of the parts of the equation together. Now we need to go ahead and solve this equation. And remember your order of operations. First, you want to start with parentheses. So we can go ahead and solve whatever's in these parentheses first. Okay, 0.08 divided by 1 is just 0.08. Add 1 to 0.08 and we have 1.08. All right, that wasn't so bad. Now we need to do the exponents. And our exponents kind of need to be simplified first, right? 1 times 4 is just 4. And if we take 1.08 to the fourth power, we get 1.36. So I'm just going to go ahead and continue my equation right up here. All right, now we do our multiplication. And we just got to multiply 1.36 times 3,400. And the answer is 4,625.66. All right. So even though that equation looks big, bad, and scary, it's not so bad once you go ahead and enter all of your information in. If you have any questions or need any help, feel free to ask. Just remember your order of operations as you are solving this equation.